Let's go to page 418 and let's go and do the chapter review. So first question, a question mark blank is a transformation which the original figure and its image are similar. Okay, so the transformation that makes it the original and image are similar is called dilation. Okay. Okay, number 2. So if you have triangle PQR is similar to triangle XYZ, and it says PQ over XY is equal to blank, YZ equal to blank. Okay, so what you need to do is match up the letters. So you got PQ, XY, and then you have the YZ. So YZ you can see it's going to match up with QR. Okay, see that? So it match with QR. It's called color code for you. Okay, so now the only one you're missing would be, so if you look over here, you got XY, then you have the YZ. So the next one you're missing would be XZ. Okay, so you need to get XZ. Right? Again, so you just kind of look at the letters. So now you have to figure out, okay, XZ will match up with PR. Okay, and so that would be your answer. Okay. Okay, now let's go to next one. Now if you have the letter switch, if you switch the letter like ZX, then you have to make RP. So make sure you watch the order of your letters. Okay. So again, if you have the ZX, then you need to have RP. So make sure you watch the order of your letters. Okay. Okay, number 3. Writing, describe the relationship between the ratio and proportions, and give an example of each. So ratio is comparing two numbers, and proportion is when you have two ratios that are equal. Okay. So example of that would be, if you have a ratio, it's like, for example, if you have like a, again, the answer may vary. So if you just give an example like 2/4, this would be example of a ratio. Okay, or 2:4. This is example of a ratio. Okay, ratio is when you compare two numbers, whereas proportion, okay. Proportion is when you have two ratios equal to each other. For example, if you are like like 6/10 is equal to 3/5. Okay, so this is an example of proportion. So again, ratio is when you compare the two numbers. You can write it this way or this way. Proportion is when you have two ratios that are equal to each other. Okay, so that's the difference between the two. Okay, and that's an example. Okay, so again, ratio is comparing two numbers. And proportion is when two ratios are equal to each other. Okay, number 4. The length of the rectangle. Okay, so you have a rectangle. Okay, I can draw the picture. So length, width, length, width. Okay, so again, when you see the word rectangle, right away draw a rectangle. It helps you to visualize. Okay, so length is 20. And the width is equal to 15. Find the ratio of the width. So you're looking for the ratio of the width. You have to pay attention to the order which comes first. So you want the width to length. Okay, so that's what you want. Okay, and then you want to simplify the ratio. Okay, so you just put a number, so it'd be 15 to 20. Okay, and if you simplify, if you divide it by 5, you get 3/4. Okay. Now, if you write it as a fraction, that's fine. So the first one comes on top, okay? 15/20, and this will equal to 3/4. So either one is fine, okay? Personally, I like to do it this way, because this way you can kind of keep track of which one comes first. This way, sometimes you kind of forget, okay, which one goes on the top, which goes on the bottom, okay? Okay, number 5, the measure of the angle. Okay, find the measure of the angles. Okay, so you have the ratio of 1 to 2, right? So these are the 3 angles in the triangle. Okay, so what you do is you point a multiplier. Okay, so you got 1x to 1x to 2x. So the x is a multiplier to get back to the original number. And so you're going to get x plus 2x equal to 180 degrees. Because the three angles in a triangle add up equal to 180. Okay, so now you can get 4x equal to 180 divided by 4, so x equal to 45. Okay, so once you find x equal to 45, then you can go back and find the original numbers. So the three angles would be 45 degrees for the x, and the 45 degrees for the x, and then 90 degrees for the 2x. And this would be your three angles. Okay, so again, 45 is what you need to multiply to get back to the original number. Again, so this is your original number. If you reduce, you're going to get 112, right? So again, whenever you have ratio, you also point a multiplier to get back to your original value. Okay? Okay, let's go to number 6. Okay, find the geometric mean of 8 and 12. So you got 8, blank, and 12. Okay, so that's what this means. Okay, to find the geometric mean, okay, if it's arithmetic mean, you just find the average. Okay, you just add, divide by 2. That's how you find the arithmetic means. But for geometric, you have to multiply and take the square root. Okay, so for this number, you can just take the square root of 8 times 12. Okay, so 8 times 12 and take the square root. And so this will equal to, now to simplify this, you don't want to multiply into a huge number. What you want to do is break down into the perfect squares. So 8, you can break into 4 and 2. Okay, you can take out the perfect square first, and the 12 can become 4 and 3. Okay, and so now notice you got 2 4. So this 2 radicals becomes a 4. Okay, and the leftover would be just square root of 6, and it would be your answer. Okay. Okay, number 7. Okay, you have this picture over here, and you have the M, N, R, P, and you have the Q, L. Okay, so this is 6, 10, and 4. Notice I write the numbers inside to represent the numbers over here. And the whole thing, I would write it outside. So if the number is on the outside, that means the whole thing. Okay? So try to keep habit doing that. It will less confusing when the problems get complicated. Okay, so you're looking for RP, so you can call this X. Okay? And so again, this is, they kind of give you the proportional rate, right? They give you Rn. So it's kind of really easy because they already give you the proportional rate. So Rp equal to Qm over QL. Okay, so Rn is 4, I just substitute, right? Rp is X, Qm is 6, and QL is 10. Okay, so after that you just have to solve, right? So cross multiply, I'm going to move it. So 6x, so cross multiply equal to 40, okay, and then divide by 6, so x will equal to 20 over 3. Okay, and you just keep it as an improper fraction. Okay, don't waste time trying to make into mixed numbers. Okay, number 8. So this is B, D, C, and this is 5, and this is 4, this is 10, so this is 14. Notice it becomes automatic, right? Whenever they give you partial length, write down the total length. If they give you a total length, figure out the partial length. Okay, just get in the habit of doing that, and let it become like automatic. Okay, so again, they give you the ratio already, right? CD over DB equal to CE over EA, and you're looking for CD. Okay, so you can CD, you don't know, so call it X, right? So you got X over DB, that's 5, and you got CE is 10, EA is 4. Okay, okay, so you can cross multiply, right? So you got 4x equal to 50, divide by 4, so x equal to 25 over 2. Okay. Okay, now let's go to number 9. Okay, in exercise 9 and 10, determine whether polygons are similar. Okay. So they got 8 and 12, and this one is 6 and 9. Okay, so what you do is go ahead and, again, there are many ways you can do this. Okay, you can look at the ratio, or you can just do this. Arrange from the shortest to the longest and reduce it. Divide by 4, you get 2 and 3. Again, arrange from the shortest to the longest, and again reduce. So 3, 2, and 3. So yes, okay. And find the scale factor. Okay, so the answer is yes. And the scale factor, so SF is scale factor, equal to 2 to 3. Okay. Okay. Oh, back up. This is not correct. Scale factor is this over here, 4 to 3. Yeah, sorry about that. Yeah, this is the reduce, so scale factor is this number right over here. Okay? And make sure you answer the question. Okay? Determine whether polygons are similar. Okay, so the answer that yes. If they are, write a similarity statements. Okay, we have to write the similarity statements. Okay, so this is A, B, C, D, and this is F, G, H, E. Again, make sure you always read the question carefully. Make sure you answer all questions. Okay, so let's go and just go A, B, C, D is similar to. Okay, so this is the long way first. Okay, and so you have to do the long way first. So B doesn't matter if you go this way or this one. I'm just going to by alphabetical. Okay, so be E. So you can go long, short, long, short. So I'm going to go long, short. Okay, long, short. Okay, as long as you mess up the letters carefully, then you're fine. Okay, again, the answer very depends on where you start. If you start over here, then you'll be G, H, E, F, right? Okay, so I'm just match up the length. Okay, so that answered the similarity statement and found the scale factor. Scale factor is 4 to 3. Okay, so that's it. Okay, okay, let's go to number 10. Okay, so you have this triangle. So you got 15, 20, 25, and you got X, Y, Z, and you have this triangle here. You got 6, 8, 10, and you have the Q, R, P. Right? So again, you can do using a ratio, okay, or you can do. I kind of like the other method. I like to do the short, medium, long, and just going to divide by 5. I got 3, 4, 5. This one I got the 6, 8, 10. Divide by 2. I get 3, 4, 5. So again, you can see that. So this is yes. Okay. So this answer, the first part is yes. They are similar. Okay. Now you have to write a similarity. So again, first I'm just write alphabetically. So it'd be X, Y, Z. Now this is a triangle, so you have to write triangle, similar to triangle. Okay. Now this you have to watch out your letter. Okay. So X is opposing to the 15, the shorter side. So you have to look for the letter facing the shorter side. Okay, see that? 15 match with the 6. See that? Okay, so the X have to match with the one facing the 6 would be P. Okay, and then the Y is facing the medium length. Okay, so the medium length is it's over here, so it's Q. Okay, and then after that, the Z is a right angle. Okay, so Z is where the right angle is, so it match up with R. Okay, so that's your similarity. And then you have to do the scale factor. Okay, so the scale factor would be these numbers over here, so it would be 5 to 2. Okay, if you write it in ratio, then it's 5 over 2. Okay. Now another way to do this is you just go and you find the ratio of the like the longer and the shortest with the shortest, so it'd be like 15/6. Okay, this over that, so it'd be 5/2. Okay, and then you can medium length 20/8. You can divide by 4, you get 5/2. And the longest length, you get 25/10 equal to 5/2. Okay, so this is a different way of doing it. So you can do either this way or this way. Okay. Now, advantage of this is that you get the scale factor already of 5/2. Okay. Okay. So let's go to number 11. Okay. So number 11. Okay, posters. It said two similar posters have a scale factor of 4 to 5. Okay. The large poster parameter is 85, and find the small poster's parameter. Okay. So you can, nice thing about it, if you line things up, whatever you see, that's your equation. Okay. So you can, it's 4 to 5. So and make sure you pay attention, right? So two similar posters. So this is small, and this is large, right? So as long as you line things up, and whatever you see, that's your equation already, okay? And to solve, okay, so you got 4/x equal to 5/85, okay, cross multiply, so you got 5x equal to 4 times 85. Again, you don't have to waste time to multiply out, okay, especially if you do it without calculator, then you divide by 5, this will cancel out, okay, this will cancel out to be 1, 7, so x would be equal to 68, okay? And watch out for the label. The label is inch. Okay, make sure you include the label in your answer. Okay. Okay, let's go to next one. Okay, number 12. It says use AA similarity partial to show that triangles are similar. Okay. So number 12, you have okay. So this one is 35 degrees. So this is kind of like a proof. Okay. Okay, so you have angle Q is congruent to angle T, so this is given, okay, and you're going to have an angle, this angle over here, so you're going to, again, when you have a triangle corner to corner, you use vertical angles, so you're going to have angle RSQ is congruent to angle, okay, you have to watch your letter carefully, okay, so you start with a letter, okay, that is don't have the number, so you start with a letter start with an angle with no letter, no numbers. So again, R has no number, so U has no number, right? And then you go S is the same number, and same angle, and then Q is the one with a number, so match with T. So make sure you match your letters carefully, and the reason would be vertical angles are congruent. Okay, you can just vertical angles. Okay, are congruent. Okay, that's a reason, and therefore, triangle RSQ is similar to triangle. Since you already have the letters already, you just use the same letter. That way, you don't have to try to refigure out the letters. Okay, and the reason would be AA. Okay, and that's the proof. Okay, so let's go to number 13. Okay. So from here, you can say that the angle B, measure of angle B is equal to 180 minus 90 minus 60. Okay, because the reason would be the angle, the sum of angles in triangle equal to 180 degrees. Okay, and then from here you got measure angle B equal to 30 degrees, and this would be just subtraction. Okay, so once you get 30, right? Now you can see that, so you can have an angle C is congruent to angle F, okay? And because of okay, so the right angles are congruent, and then you have an angle B is congruent to angle E, and this would be definition of congruence, okay? Because they have the same measurement, therefore they have to be congruent, okay? And now you have two angles are congruent, then you can say triangle ABC is similar to triangle, again, match your letter, okay? So this will match with D, and then B match with E, and C match with F. So you can make sure you pay attention to how to match up the letters, and the reason would be, again, is AA, right? Because you got two angles are congruent. Okay, number 14. Okay, cell tower. A cellular telephone tower casts a shadow. Okay, so you have a tower, and it casts a shadow that's 72 feet. Okay, while a tree nearby, that is 27 feet tall, casts a shadow of 6 feet. Okay, and how tall is the tower? Okay, so again, because the shadow, they have to be similar triangle. So whatever you see, that's going to be your equation. So you got x over 72 equal to 27 over 6. Okay. Now for this type, you don't want to cross multiply, because when you cross multiply, you have extra step. Okay, when the variable is on the top, the easier thing to do, just go and get rid of 72. So just multiply by 72 on both sides. Okay. If you cross multiply only when you have the variable in the denominator. Okay. Okay. So now this will cancel out. So you got x equal to, now this one you can use your calculator or you can reduce. Okay. Doesn't matter. So that's going to use calculator. So you got 27 times 72 divided by 6 will equal to 324 feet. Don't forget your label. Okay. Okay, let's go to the next one. Okay, so this is 4, this is 8, so you can right away get in the habit of doing that. Put a partial length on the inside, put a total length on the outside. When they give you partial length, go and automatically get the total length. Okay, this is 3.5, and this is 7, so right away is 10.5. Okay? Okay, use the SS similarity theorem or SAS similarity theorem to show that the triangles are similar. Okay? Okay, so this one you want to use the SAS, okay? So this one, see, you got, so the small triangle is 4. So you have the CB over CA, okay, equal to, so 4, see this is 1/3 of that, this is 1/3 of that, okay, so you have, so you have this side over this equal to 4 over 12, okay, equal to 1 over 3, right? The small triangle compared to the big triangle. And then you have the small triangle, the CD over CE equal to 3.5 over 10.5, which is equal to 1 over 3. Okay, see that? Okay. And then you have the angle ACE is congruent to angle BCD. Okay, so this is reflexive. Okay, the same angle equals itself. So this is the angle for the big triangle, also the angle for the small triangle. So you're going to have the SAS. Okay. Okay. So that's how you get the SAS. Okay, number 16. Okay, it's going to be the same thing except the triangles are turned kind of sideways now. Okay. Okay, so this is 15, this is 10, this is 4.5, this is 9, so this will be 13.5, this is 7, this is 14, so that is 21. Okay, so this one you have to use the SSS because none of the angle is giving. Actually, you can use this one too. Okay, so you can use so they want you, since we already did the SAS, so this one we're going to do the SSS because all the lengths are giving. But this one technically you can use SAS also. Okay, so let's go and do the SSS. Okay, since we already used that, let's go and try the SSS. Okay, so we're going to have the QU, so small triangle over the big triangle, okay, equal to 9 over 13 over 5. Okay, and if you to reduce, okay, you're going to get, if you divide by 4.5, you're going to get 2 over 3. Okay, so that's this side. Now let's go and do this side over here. So I got QR, the small triangle, over the big triangle, QS. So equal to 14 for the small triangle and over 21. Now you see that's a reason that whenever I give you partial length, we automatically just going to do the total length. And you can divide by 7, you get 2 over 3. Okay? And then do the other side. So you have the UT over T UR. So U is 7. So UR over TS. So equal to 10 over 15 divided by 5 equal 2 over 3. So since they are all the same, so that's your SSS. Okay. Now if you do the SAS, then you don't need this one. Okay. So if you have this, then you do the angle UQR is congruent to angle TQS. Okay, that would be this angle over here. If you do that, if you do this part over here, then you get SAS. Okay, but if you do the blue one, you get SSS. So you can do either one. Okay. Okay, let's go to the next one. Okay, use the given information to determine whether they are parallel. Okay. Okay, so remember the proportional. We have E already. So if the lines are parallel, then they will be proportional. If they are proportional, the lines will be parallel. So you can go either way. So what I'm going to do is, so this would be 26 and this would be 48. Okay, but we don't need that. We can just go and use this over this and this over this. Okay, so 16 over 10 equal to, so this over this will equal to 8 over 5. Okay. And 28 over 20 equal to divide by 4, I get 7 over 5. Okay, so this is no. Okay, so this answer is no because they are not the same. Okay, so no or not parallel. Okay, not parallel. Okay, so either one. Okay, probably this is more clear. Okay, number 18. Okay, so this is 13.5, this is 12, 22.5, and 20. So again, this would be 32 out here. So you add, so it'd be 35, 36. Okay? Okay, so I'm going to compare. Again, you can compare this with this. Okay, it doesn't matter. So I'm going to use this over that. So 22, okay, 0.5. Again, you can use this over that or this over this. Doesn't matter. You can do either way. Okay, I'm just going to try over 13.5. Okay, and then it will reduce. First, I'm going to remove the decimal. Okay, reduce the decimal. Get rid of the decimal. Then reduce by 5. So that's going to try reduce by 5. Okay, so it'd be, again, you can use your calculator. Okay, so 225 divided by 5, I get 45. And 135 divided by 5, I get 27. And this one you can divide by 9, so it'd be 5 over 3. Okay, so that is this one here. Okay, so I'm going to do this side now. Okay, so now you have to be careful. It's this over this, so you have to use this over that. So it'd be 20 over 12. Okay, I'm going to color code a little bit. This one is much easier to reduce. Okay, so this will equal to, if you divide by 4, you get 5 over 3. So these are yes. So then says yes, period. Okay. Okay, let's go to 19. Okay, draw a dilation of the polygon with a given vertex using the scale factor k. Okay. Okay. So this one you're going to need graph paper. So let's get graph paper. Okay, let's go. Now, when you're drawing this, do not rescale. You're going to mess it up. Yeah. Okay, so T is 0, 8. So 0, 8. So that's T at 0, 8. And U is 6, 0. And V is 0, 0. Okay. I'm going to use this too. Okay, so you have this triangle here. Okay, so if you do your work, right, 0, 8, and I'm going to call it T prime. So multiply by 3 over 2, so it's still going to get 0 and 12, right? Again, multiply by 3 over 2 for every number. And U is at 6, 0, so U prime, okay, so it would be 9, 0, okay, and then the D is at 0, 0, so the D prime is still going to be 0, 0, okay, so 0, 12, okay, so there would be T prime, should be 0, 12, and U prime is 9, 0. And the V prime is 0, 0. Okay? So you're going to end up with this triangle over here. Okay? Okay. Let's go to next one, number 20. Okay, number 20, you have an A at 6, 0, B at 3, 9, and C is at 0, 0, and D at 3, 1, and K equal to 4. Okay? Okay. Now, we actually don't have to waste time. It did not ask us to draw the original. Okay? So we don't have to draw the original. It did not ask for original. So we can just draw the image already. Okay. So from here we're going to get A prime. Okay. So that's the image. So everything times by 4, so you're going to get 24, 0, and B prime is going to be 12, 36, and C prime is going to be 0, 0, and D prime is going to be 12, 4. Okay. Now, obviously, if you thought that this is going to be huge, right? So this is when you can go ahead and I am going to make everyone equal to 4 because scale factor is 4, so you know that everything is going to be multiple 4. So when you rescale, you have to kind of do that so that people know that every square equal to 4. Okay? Okay, so 24, you can actually follow that. If you scale it into 4, then so you just go 6, 0. Okay? So go 1, 2, 3, 4, 5, 6. Okay? And you can see that 4, 8, 12, 16, 20, 24, right? Okay, so that's your A prime is a 24, 0. So when you rescale, do not put a hash mark into the square. Yeah? Okay, then you got 12, 36. Okay, 36, so it'd be 9. Okay, so again, if you make every square equal to 4, then you can just actually use this number to figure out the square. So you go 3 squares and 9 squares. Okay, and this would be your B prime, would be 12, 36. Okay, and C prime is 0, 0. Okay, and then D is 3, 1, right? So it'd be 3, 1. Okay. Okay, double check. Okay, you got 6, 0, 3, 9, 0, 0, 3, 1. Okay. Okay, so actually this is wrong. Okay, you have to watch your X and the Y. This one have to go X first. Okay, so here's your A prime is 24, 0. Okay. Yeah, so watch your X and the Y. So this is not correct. Okay. And we have to label this. So A, B, C, D. So this is point D. Okay. Now, when you connect that, you have to follow the order, right? So it'd be from A to B, from B to C. Okay, I'm going to use this then. Okay, A, B, C, and go to D. So when you plot, again, watch out for your X and the Y, okay? And again, notice if you do it smartly, then see if the K equal to 4, and if you make every square equal to 4, then this would be the number of square that you're using, okay? And make things a lot easier to plot. Okay? Okay, let's go to number 21. Okay, number 21, the P is A2, Q is a 40, R is a 31, and S is a 64. And K equal to 0.5, so P prime would be 41, and Q prime would be 20, R prime would be 3/2 or 1.5, that's okay, 1/2, okay, and then S prime would be 3, 2. Okay, so that's going to plot that. So 4, 1, again, watch your X and the Y, okay, so that's your P prime at 4, 1. Q is 20, and R prime is 1.5, 1/2. So that's R at 1.5, 0.5. And S is 3, 2. Okay, so your picture, so P, Q, R, S. Okay, so that would be the picture. But again, if you do like what we did last time, if you make every square, if you use every square equal to 0.5, so if you make every square equal to half, then you can use, this will give you a number of squares. Okay, that way you don't have to do like halfway like that. So again, if you make every square equal to the scale factor, then this would be the number of square that you count. Okay, so that would make things a lot easier.